In California, the California Electrical Code, known as the CEC, and the California Fire Code, called the CFC, govern the electrical classification of hazardous classified areas. CEC Section 500 addresses hazardous locations. It provides requirements for the installation of electrical equipment in hazardous locations where flammable gases or vapors, flammable liquids, combustible dust, or ignitable fibers are present. It references relevant sections of the National Electrical Code, known as the NEC and NFPA 70. CFC Part 5 concerns hazardous materials. It includes requirements for the classification and protection of hazardous materials and facilities, including those associated with power plants. API Recommended Practice 500 offers guidance on the classification of hazardous areas based on the likelihood of flammable substances being present. This is commonly used in the petroleum industry, but can also be applied to other industries, such as power generation. When designing for high-pressure natural gas, consider the use of API Recommended Practice 500 Figures 104.5 and 105. These figures provide recommended hazardous area classification distances for natural gas leaks. The 25-foot distance is based on a leak rate of 450 SCFM of 500 SIG. The design basis should be based on the specific conditions of a plant, including the actual leak rate, location of potential leak sources, and plant layout. The application of API Recommended Practice 500 is not mandatory and requires engineering judgment to ensure appropriate safety measures are implemented. The California Department of Industrial Relations, referred to as DIR, Division of Occupational Safety and Health, DOSH, reviews plans for Class 1, Division 1 and Division 2 hazardous areas. The local authority having jurisdiction, or ODJ, enforces the CEC and CFC, including requirements for electrical classification and hazardous areas. Firstly, it is recommended to consult with DOSH and the local AHJ to determine their specific requirements and expectations for high-pressure natural gas classification. Secondly, consider engaging a qualified electrical engineer with experience in hazardous area classification to review the design and provide guidance. Thirdly, document the design basis and assumptions, including the leak rate and plant layout used to determine the classified areas. API Recommended Practice 500 provides guidelines for classifying locations where electrical installations are present in petroleum facilities, specifically those classified as Class 1, Division 1 and Division 2. These classifications are used to determine the appropriate types of electrical equipment and wiring methods to use in hazardous areas to prevent explosions and fires. The NEC and the CEC Article 500 contains the general requirements for electrical equipment and wiring in hazardous locations. It covers the different classes, divisions, and groups of hazardous locations, as well as the types of protection methods that are permitted in each location. The CEC adopts and modifies the NEC for use in California. Article 505 of the NEC covers zone classifications, which are an alternative method of classifying hazardous locations that is based on the frequency and duration of the presence of flammable gases or vapors. Zone classifications are becoming increasingly common, particularly in international applications. The California Fire Code contains requirements for fire prevention and fire protection in buildings and facilities. It includes requirements for the storage, handling, and use of flammable and combustible liquids and gases, as well as requirements for fire detection and suppression systems. In the context of electrical classification, the CFC requires that hazardous areas be classified in accordance with the NEC or API Recommended Practice 500. API Recommended Practice 500 provides detailed guidance on how to classify hazardous areas based on the properties of the flammable materials present, the likelihood of releases, and the ventilation conditions. It includes figures and tables that can be used to determine the extent of hazardous areas around potential sources of release. The California Department of Industrial Relations, Division of Occupational Safety and Health, is responsible for enforcing workplace safety regulations in California. This includes regulations related to electrical safety in hazardous locations. DOSH may review plans and inspect facilities to ensure that they comply with the requirements of the CEC and the CFC. The local authority having jurisdiction is the local government agency that is responsible for enforcing building codes and fire codes. This could be a city, county, or other local government entity. The AHJ has the authority to approve or disapprove plans for electrical installations in hazardous locations and to inspect facilities to ensure that they comply with the applicable codes. It is important to consult with the AHJ early in the design process to ensure that the plans meet their requirements. When designing electrical installations in hazardous locations in California, it is essential to comply with the requirements of the CEC, the CFC, API Recommended Practice 500, and any applicable regulations from DOSH and the local authority having jurisdiction. Consulting with qualified professionals, such as electrical engineers with experience in hazardous location design, can help ensure that the design meets all applicable requirements and provides a safe and reliable electrical system. The classification of hazardous areas is a critical aspect of electrical safety in facilities that handle flammable or combustible materials. The correct classification of these areas is essential for selecting appropriate electrical equipment and wiring methods to prevent explosions and fires. There are several key steps involved in the process of classifying hazardous areas. The first step is to identify all potential sources of release of flammable or combustible materials. This includes equipment such as pumps, valves, tanks, and pipelines that could leak or spill these materials. It also includes areas where flammable vapors or gases could accumulate, such as enclosed spaces or areas with poor ventilation. The second step is to determine the properties of the flammable or combustible materials present. This includes information such as the flash point, auto-ignition temperature, and lower and upper explosive limits of the materials. This information is used to assess the potential for ignition and the severity of a potential explosion or fire. The third step is to evaluate the likelihood of releases of flammable or combustible materials. This depends on factors such as the design and condition of the equipment, the operating procedures, and the maintenance practices. Areas where releases are more likely to occur will be classified as more hazardous. The fourth step is to determine the extent of the hazardous area. This is the area around a potential source of release where flammable or combustible materials could be present in sufficient concentrations to create a hazard. The extent of the hazardous area depends on factors such as the rate of release, the properties of the materials, and the ventilation conditions. API Recommended Practice 500 provides guidance on how to determine the extent of hazardous areas based on these factors. The fifth step is to document the classification of hazardous areas. This includes preparing drawings and diagrams that show the location and extent of each classified area. It also includes documenting the basis for the classification, including the factors that were considered and the codes and standards that were applied. The classification of hazardous areas should be reviewed and updated periodically to ensure that it remains accurate and reflects any changes in the facility or its operations. It is also important to train employees on the classification of hazardous areas and the safety procedures that are required in these areas. There are three classes of hazardous locations: Class 1, Class 2, and Class 3. Class 1 locations are those where flammable gases or vapors are or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Class 2 locations are those where combustible dust is or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Class 3 locations are those where easily ignitable fibers or flyings are present but not likely to be suspended in the air in quantities sufficient to produce explosive or ignitable mixtures. Each class of hazardous location is further divided into divisions based on the likelihood of the hazardous material being present. Division 1 locations are those where the hazardous material is normally present or may be present frequently. Division 2 locations are those where the hazardous material is not normally present but may be present accidentally. In addition to classes and divisions, hazardous locations may also be grouped based on the specific flammable or combustible materials that are present. The NEC and CEC specify different requirements for electrical equipment and wiring depending on the class, division, and group of the hazardous location. Electrical equipment that is installed in hazardous locations must be designed and tested to prevent explosions and fires. This typically involves using explosion-proof enclosures, intrinsically safe circuits, or other methods of protection. Wiring methods must also be designed to prevent the ignition of flammable or combustible materials. This may involve using sealed conduit, mineral-insulated cable, or other special wiring methods. It is essential to select electrical equipment and wiring methods that are appropriate for the specific class, division, and group of the hazardous location. The NEC and CEC provide detailed guidance on the types of equipment and wiring methods that are permitted in each location. Improperly selected or installed electrical equipment can create a significant risk of explosion or fire in a hazardous location. In addition to selecting appropriate electrical equipment and wiring methods, it is also important to implement other safety measures to prevent explosions and fires in hazardous locations. These measures may include ventilation, grounding and bonding, and the control of static electricity. Ventilation is used to remove flammable vapors and gases from hazardous locations and to prevent them from accumulating in dangerous concentrations. Grounding and bonding are used to prevent the buildup of static electricity, which can be a source of ignition. The control of static electricity may also involve the use of static dissipative materials and equipment. Regular inspections and maintenance are essential to ensure that electrical equipment and wiring in hazardous locations are in good condition and are functioning properly. Inspections should be conducted by qualified personnel who are familiar with the requirements of the NEC SEC and other applicable codes and standards. Maintenance should be performed in accordance with the manufacturer's recommendations and should include regular cleaning, lubrication, and testing of equipment. Any damaged or defective equipment should be repaired or replaced immediately. The safe operation of facilities that handle flammable or combustible materials requires a comprehensive approach to electrical safety in hazardous locations. This includes proper classification of hazardous areas, selection of appropriate electrical equipment and wiring methods, implementation of other safety measures, and regular inspections and maintenance. By following these guidelines, it is possible to minimize the risk of explosions and fires and to protect people and property from harm. The design of electrical systems in hazardous locations requires a thorough understanding of the applicable codes and standards, as well as the properties of the flammable or combustible materials that are present. It is essential to consult with qualified professionals, such as electrical engineers with experience in hazardous location design, to ensure that the design meets all applicable requirements and provides a safe and reliable electrical system. Engineering judgment plays a crucial role in the application of API Recommended Practice 500 and other guidelines for electrical classification in hazardous areas. While these guidelines provide a framework for classifying areas based on the potential for flammable or combustible materials to be present, they cannot account for every possible scenario. Engineers must use their knowledge and experience to assess the specific conditions at a facility and to make informed decisions about the appropriate classification of hazardous areas. One area where engineering judgment is particularly important is in determining the extent of hazardous areas. API Recommended Practice 500 provides formulas and tables that can be used to calculate the distance from a potential source of release where flammable or combustible materials could be present in sufficient concentrations to create a hazard. However, these calculations are based on certain assumptions about the rate of release, the properties of the materials, and the ventilation conditions. In some cases, these assumptions may not be valid, and engineers must use their judgment to adjust the calculated distances accordingly. For example, if a facility has particularly good ventilation, the extent of the hazardous area may be smaller than what is calculated using the API Recommended Practice 500 formulas. On the other hand, if a facility has areas where flammable vapors or gases could accumulate, the extent of the hazardous area may be larger than what is calculated. Another area where engineering judgment is important is in selecting appropriate electrical equipment and wiring methods for hazardous locations. The NEC and CEC specify different requirements for electrical equipment and wiring depending on the class, division, and group of the hazardous location. However, there may be multiple types of equipment and wiring methods that are permitted in a particular location. Engineers must use their judgment to select the equipment and wiring methods that are best suited for the specific application, taking into account factors such as the cost, reliability, and maintainability of the equipment. Engineering judgment is also important in determining the appropriate level of safety for a hazardous location. The goal of electrical classification is to prevent explosions and fires, but it is not always possible to eliminate the risk entirely. Engineers must use their judgment to balance the level of safety with the cost and practicality of implementing safety measures. In some cases, it may be necessary to accept a small risk of explosion or fire in order to avoid excessive costs or operational constraints. The use of API Recommended Practice 500 is not mandatory, but it is widely recognized as a best practice for classifying hazardous areas in the petroleum and chemical industries. However, it is important to remember that API Recommended Practice 500 is only a guideline, and it should not be applied blindly. Engineers must use their judgment to adapt the recommendations of API Recommended Practice 500 to the specific conditions at their facility. The California Department of Industrial Relations, Division of Occupational Safety and Health, is responsible for enforcing workplace safety regulations in California, including regulations related to electrical safety in hazardous locations. DOSH may review plans and inspect facilities to ensure that they comply with the requirements of the CEC and the CFC. DOSH also has the authority to issue citations and penalties for violations of safety regulations. The local authority having jurisdiction is the local government agency that is responsible for enforcing building codes and fire codes. This could be a city, county, or other local government entity. The AHJ has the authority to approve or disapprove plans for electrical installations in hazardous locations and to inspect facilities to ensure that they comply with the applicable codes. It is important to consult with the AHJ early in the design process to ensure that the plans meet their requirements. The specific requirements and expectations of DOSH and the local authority having jurisdiction can vary depending on the location and the type of facility. It is essential to consult with these agencies to determine their specific requirements and to ensure that the electrical design meets all applicable regulations. The California Electrical Code is based on the National Electrical Code, which is a widely adopted standard for electrical safety in the United States. However, the CEC includes some modifications and additions to the NEC to address specific conditions and concerns in California. It is important to use the most recent edition of the CEC when designing electrical installations in California. The California Fire Code contains requirements for fire prevention and fire protection in buildings and facilities. It includes requirements for the storage, handling, and use of flammable and combustible liquids and gases, as well as requirements for fire detection and suppression systems. The CFC requires that hazardous areas be classified in accordance with the NEC or API Recommended Practice 500. It is important to comply with the requirements of the CFC when designing electrical installations in hazardous locations. The design basis for electrical classification in hazardous locations should be based on a thorough understanding of the applicable codes and standards, as well as the properties of the flammable or combustible materials that are present. The design basis should also take into account the specific conditions at the facility, such as the ventilation, the operating procedures, and the maintenance practices. The design basis should be documented in detail, including the assumptions that were made and the calculations that were performed. The documentation should be reviewed and updated periodically to ensure that it remains accurate and reflects any changes in the facility or its operations. It is also important to train employees on the design basis and the safety procedures that are required in hazardous locations.